In this presentation, we're going to talk about meters and meter usage. Now, this is a subject that is going to follow you through the rest of the trade. Okay, every service call you go on, most installations you do, someplace along the way you're going to be using your meter. This is extremely important to understand some of the concepts presented here, because in order to properly use your meter, you have to realize what you should be getting and what you should be reading versus what you are reading. That's how you troubleshoot a system. Okay, the meter is your most often used tool as an HVAC technician. Should be the first tool out of the tool bag and the last tool you put away. Just a quick note that you probably should read the manual that came with your meter to understand its functions. Every meter is a little bit different. We have two basic types of meters. We have an analog meter and we have a digital meter. The analog meters have been in the workforce for years. They're extremely sensitive and they don't stand up well to being tossed around in trucks. They're still used today when technicians are looking for very accurate measurements. This is an example of an analog meter. You notice it has a gay needle on it up here, and it also has a lot of positions on the dial, which is called ranges and functions. Okay, so they're really great for accurate measurements, but if you ever have one, don't just leave it laying around your truck. Digital meters have almost completely replaced the analog ones in the industry. Digital meters stand up much better to being dropped, tossed around a truck, and a wide variety of temperature ranges. Digital meters are accurate and usually auto range. This is an example of a digital meter. Okay, you notice that the display is a lot easier, a lot less ranges on the dial. It's mostly function selections. Most of these meters do what we call auto range. They'll select the best measurement for whatever reading you're taking, or the best accuracy. We have to talk about first a few electrical rules before we can understand how the meters work. Okay, most of these rules are based on voltage, amperage, and resistance because those are the key things you're going to be using when troubleshooting. Series circuits are important to understand. You're going to hear technicians and technical support staff talk about things in series with something else. Series means in the same line as. This is an example of series. The first ball, the red ball, is in series with the second ball and the third ball. Okay, so the red, blue, and green are in series with each other. Parallel means next to, but never converging or diverging. Okay, we're going to talk about things that are in parallel with each other. This is an example of a parallel circuit. Okay, or parallel example. The first, second, and third ball are all in parallel with each other. They're not touching, they're next to each other. Open circuits are circuits that do not have a complete path for electricity to flow. Remember, circuits require a source, switch, path, and load. If any of these components has a break or an open in it, the current cannot complete its circuit. This is an example of an open circuit. Simple circuit. B1 is a bulb. Okay, L1 in neutral, or L2, doesn't really matter, is our source. We have our wires connecting, but we have a switch. Okay, the switch is in its open position. So current cannot complete the flow from N to L. Okay, because switch 1 is open. The break here means that current cannot move through. So when switch 1 is open, the load will be off because there's no direct path for electricity to flow. When you measure voltage across an open circuit, you will always get a reading of source voltage as long as your meter probes are on each side of the open. Source can be 24 volts, 120 volts, 208, 277, 480. Okay, but again, the key to remember, when you measure voltage across an open circuit, you will always get a reading of source. When you measure resistance across an open circuit, you will always get a reading of infinity, or on most of your meters, OL if it's a digital meter. Okay? But it really stands for infinity. A closed or complete circuit is a circuit that has a complete path, source, switch, and load. When the load is operational, if it's a good load in a complete path. The switch is closed in a complete circuit. So this is the same example again, but with a closed switch. Again, notice I have a complete path from neutral through my load, through the switch, back to L1. So that is a complete circuit. When measuring voltage across a closed switch in a complete circuit, you get 0 volts. There's no difference in potential. When measuring voltage across a complete circuit, you will get source. Okay, so again, we want to go back to this other diagram. If I measure voltage, okay, from here to here, I'm going to get 0. If I measure voltage from here to here, I'm going to get whatever the source is. Voltage across a load is identical if the load is working or if the load is bad. If you have all switches closed and measure voltage across the load, the circuit is good. If the load is not working, then you have a bad load. If the load is working, then the voltage you're reading is the voltage the load is using or the voltage drop across the load. Measuring current in a circuit, okay, will be 0 in an open circuit. Again, there's no path for the current to flow from neutral back to line. In a closed circuit, the amperage you measure may change based on where you take your readings. Meters will measure voltage, current, resistance, capacitance, frequency, and temperature. Voltage is the most frequent measurement you make. Now, here's the thing here. When you are troubleshooting, most of the time you are troubleshooting in a live circuit. So it's extremely important to remember your safety procedures. To measure voltage, you turn your meter on, set it to volts or V, depending on what your dial shows, and make sure your leads are plugged into the correct place on the meter. Put the leads in parallel or next to the point in the circuit you are trying to measure. Hold the lead steady without touching any of the metals with your fingers or each other. Watch the display until the meter stabilizes on a number. That is your reading. So again, when you're measuring voltage, you're putting the meter in, here's your meter, the 120 in blue is your meter. These are your two leads. You're putting your meter in parallel or next to the voltage you're trying to measure or the component you're measuring voltage on. Voltage across an open switch is always source. If you get anything else, there's another problem. Voltage across a closed switch is always 0. Voltage across a non-powered load will be 0 because there's no potential to do work. Voltage across a powered load is always source. Now, if the load is bad, okay, it's going to act like an open switch. Notice the broken wire in here. So again, then we go back to voltage across an open is source. So what is the difference in voltage readings between a powered load and a non-powered load? It's going to show the same thing on the meter. Okay, powered load that's working, powered load that's not working. The difference is the load is not working. Okay, so if I have a light bulb, and if I'm getting 120 volts across it, and if the bulb is out, it means the bulb is bad, replace the bulb. If I'm getting 120 volts across it and the load is good, okay, circuit's working properly. The voltage across a full circuit, regardless of the switch is open or closed, is always source. And that is because if it's a closed switch, you're really taking a measurement in parallel with the load. If it's an open switch, you're taking the measurement in parallel with the open switch. To measure resistance of a circuit, you have to disconnect the circuit from the source. Do not ever measure resistance on a circuit that's plugged in or powered. You will burn your meter out. Decide what component or portion of the circuit you would like to measure. Disconnect a wire to or remove that part. Set your meter to ohms. Touch one lead directly to another. This will show as meter a reading of 0 on your meter, that means your meter's good. If it doesn't, check and make sure that your leads aren't damaged and they're plugged into the right spots. Now, touch one lead to each side of the component or isolated portion of the circuit that you're testing. Wait for the display to stabilize and record that number. This is the resistance. Resistance is always shown in ohms. Resistance across an open switch will be OL, or infinite. Resistance across a closed switch will be 0. Resistance across a working load or good load is some number. It's going to vary by the load. You can't say 0 or infinite on that. Resistance across an open load, in other words, something that has an open winding or has gone bad, is OL or infinity because it shows just like the open switch. It's a break in the circuit. Current measurements, you first have to determine which type of ammeter you want to use. The clamp-on meter that most of you have is used for higher voltages and currents. The inline type meter is used for lower voltages and currents. Make sure you close the switch to energize the circuit for clamp-on, and make sure the system is running. Clamp the meter around a single wire and wait until the numbers stabilize. This is your amperage reading. If the current is too low, consider using an inline meter. If that's not possible, wrap a wire around the clamp 5 to 10 times and take your reading. Divide that number by the number you get by the number of times the wire is wrapped around the clamp for your amperage. Okay, to measure inline, using an inline meter, the meter is put in series with the circuit you want to read. In other words, you open the circuit up, remove one wire, and put one lead of the meter on one side and one lead of the meter on the wire you removed. It's measured in series. Make sure the power is turned off. Check with your voltmeter to verify. Disconnect a wire directly before the component you're concerned about and put your meter in series with the component to complete the circuit. Make sure the meter is set to amps and the leads are plugged into the correct spots. Turn the circuit back on and allow the display to stabilize on the meter. This is your amperage reading. Be very, very careful with inline that you know the levels of voltage, current your meter's rated for. Do not exceed it. You do not want to put an inline amp reading in a circuit that handles like 400 amps or even sometimes 50 amps because it might exceed the capability of your meters. If you suspect you are close, use the clamp-on method. Now, as we talk about voltage readings, most of the time you'll not have just one switch controlling a load. Most of the circuits in HVAC industry have more than one control device. You'll have safeties, you'll have other switching devices. So you'll have a whole bunch of components working together. You have to have a reliable, organized method to find problems in a circuit. That is what we call the Hop-scotch method. The procedure for this is extremely simple. First, make sure your meter is set on volts and make sure the leads are correctly plugged into the appropriate spaces on the meter. It's important to note that the Hop-scotch method of troubleshooting only applies to circuits up to 120 volts. Next, check the voltage across two endpoints of the circuit, line and neutral or line and line. Okay? First, again, check your voltage across line and line. Make sure we have source voltage. If you don't have source voltage, you have to stop right there and find out why you don't have source voltage. Okay? Now, put one lead onto the start point of the circuit. In our case, that's L1. Keep that lead there. Sometimes using the clip-on terminal is a better way to go. Use the second lead only to go from point to point in the circuit before and after each switching device and load, checking for opens until you find the problem. So, voltage across L1 and neutral is 120. You have power in the circuit. Now, leave the lead on L and move the voltage to the line side of switch 1. Okay, so voltage from L to switch 1 is 0. That actually means that portion of the circuit is good because there's a complete path. We should not have a voltage differential. Go to the load side of switch 1. We got 120 volts. That means that switch 1 is open. Remember, voltage across an open switch is always source. I can verify the problem now by starting from neutral. Okay, go back to line of neutral. Then take a voltage reading from neutral to the neutral side of B1. That wire's good. Voltage from neutral to line side of B1. No problem, voltage remains 0. Neutral to line side of switch 1 is 120. Problem found. Switch 1 is open. Now again, easy when you have a single switching device. Okay, and you can see that it's open on your schematic circuit. But remember, inside HVAC equipment, you can't see whether the internal component is open or closed. So you have to say, okay, using my meter, is that pressure switch? Is that coil? Is that contact open or closed? And you're looking for source or zero in your entire troubleshooting process.